Our next chapter is chapter 19, electrical circuits. Here we can see some circuit diagrams. These are common circuit symbols for power supply, battery, two-way switch, bell, fixed resistor, potentiometer, light dependent resistors, cell, switch, bulb, fuse, variable resistor, and thermistor. You need to remember the shapes of these symbols as it might be asked in the exams. Similarly, there are some shapes here for your better understanding, so this can also be viewed and studied for exam perspective. So you must recognize and draw these shapes. Cell, battery, switch, open and close, lamp, bulb, fixed resistor, variable resistor, thermistor, LGR, light dependent resistor, diodes, LED, light emitting diode, motor, heater, bell, ammeter, voltmeter, and fuse. Transformer. Alright, let's discuss types of components. Power supplies, cell, battery, DC power supply, it provides direct current. Then generator, AC supply, it provides alternating current. Resistors, used to control current and potential difference. Now we have fixed resistor, it supplies constant resistance. Variable resistor, resistance can be adjusted. Thermistor, resistance depends on temperature. If temperature increase, resistance decrease. LDR, resistance depends on light. Light intensity increase, then resistance decrease. Meters, we have ammeter and voltmeter. In ammeter, it measures current connected in series. Voltmeter measures potential difference V and it is connected in parallel. We have switch and functional components. Switch open closes the circuit. Lamp converts electrical energy to light and heat. Motor, it converts electrical energy to kinetic energy. Heater converts electrical energy to thermal energy. Bell buzzer converts electrical energy to sound. Then we have diodes. Allow current only in one direction, the direction of the arrow. If reversed current is blocked, LED does the same but emits light when current flows. Now we have current in circuits. Series circuits. One single loop, same current flows through all components in series circuits. Rule is, in a series circuit, the current is the same at every point. Factors affecting current in series. Higher supply voltage means more current. More larger resistors means more total resistance and there will be less current. Let's discuss parallel circuits. There are more than one loop branches. Rule here is, at a junction, current splits into branches. Total current into junction, which is equals to total current out. So current from the power supply will be equals to current sum of currents in each branch. So I total is equals to I1, I2, I3, so on and so forth. Important point here is current does not always split equally. It depends on the resistance in each branch. Lower resistance branch gets more current. Let's discuss lightning circuits. Lamps in houses are wired in parallel so that each lamp gets full supply voltage and have same brightness. In one lamp, if one lamp fails, other continue to work. Lamp can be switched on off individually. Now let's discuss EMF and potential difference in circuits. EMF in series cells. If cells are connected in series and in the same direction, E total will be equals to E1 plus E2 plus so and so forth. Example, three 1.5 volt cells in series, total EMF is given as 4.5 volts. Potential difference in a series circuits. Rule is, in a series circuit, sum of potential difference across component is equals to EMF of power supply. So V total is equals to V1 plus V2 so and so forth. So if E equals to 16 volt, V across X equals to 10 volt, V across Y equals to 16 minus 10, which is equals to 6 volt. Potential difference in a parallel circuit. Rule is that PD across each branch is parallel is equal to EMF of the source. If a battery is 12 volts, each branch has 12 volts across it. Through the 12 volt might be shared between several components in that branch. Let's talk about combined resistance. So resistance in series. Rule here is total resistance is equals to sum of resistances. R total is equals to R1 plus R2 and so forth. Adding more resistors in series increases total resistance, which means that current will decrease. Let's talk about resistors in parallel. The rule is total resistance is less than the smallest individual resistor. If the resistors are equal, two equal resistors in parallel, combined resistance will be equal to half one resistor. Extended formula for two resistors in parallel, 1 over R total, which is equals to 1 over R1, 1 over R2, so and so forth. Steps: calculate 1 over R total. Take the reciprocal to get R total. Now let's discuss potential dividers. A potential divider splits the supply voltage between two resistors in series. The key idea is the same current flows through both resistors in series. The supply EMF is shared between them. The bigger resistance gets the bigger PD. So our ratio relationship will be R1 over R2 will be equals to V1 over V2. Also for V total, we know that V1 plus V2 and that is equals to E. If one resistor is a variable resistor, changing its resistance changes how the total voltage is shared. So you can control the output voltage to a device. Example, sensor, lamp, transistor base. Typical use: sensors using thermistors or LDRs as one resistor in the divider, so output voltage changes with temperature or light. Next, we have electrical safety, common hazards, damaged insulation, exposed live wire, risk of shock and short circuit, overheating cables, too much current, insulation may melt, risk of fire. Damp conditions, water conducts electricity, increased risk of shock and short circuit. Overloading sockets, extension leads, too many appliances, too much current, which results in overheating and then fire can cause. Now let's discuss mains wiring, 3 plug-in, 3 pin plug. 3 wires color coded. If it is brown, then carries AC from the supply, most dangerous at high PD, example 230 volts. If it is neutral blue, completes the circuit close to 0 volt. Then earth, green, yellow. Safety path to earth if the case becomes live. Double insulation. Appliances has insulated wires and non-metal plastic outer case or design where live parts cannot touch the case. Result: no exposed metal that can become live. Such appliances do not need an earth wire. Let's discuss about earthing. Used when appliances has a metal case. Earth wire is connected to the metal case. If live wire breaks and touches the case, large current flows through earth wire. Low resistance path. This large current blows the fuse or trips the circuit breaker. Supply is cut off. Appliance becomes safe. Let's discuss about fuses. Safety device in plug. It is thin wire inside that melts if current is too large. Breaking the fuse breaks the circuit, cut off the current. Some fuse ratings commonly are 3A, 5A, 13A. Rule for choosing: choose the lowest rating that is still above the normal working current of the appliance. Example: appliance need 3.1 ampere of current. 3 ampere fuse will be too small, blow immediately. 5 ampere fuse will be correct for it. 13A fuse will be too large, would allow too much current before blowing. Now let's discuss circuit breakers, trip switches. Found in the consumer unit fuse box of the house. Monitor current in each house circuit. If current becomes too large, the switch trips, turns off automatically, cuts off current to that circuit. Advantages over fuses: don't need replacing, you can reset them. Quicker and more convenient. Provide protection against current surges and faults. With this, we have finished our chapter. See you in our next chapter.